Hello everyone. In the beginning of the class, let us look at new announcements. Okay, April 21st, 2022, class video uploaded, part 3. Hello everyone. I have uploaded part 3 of the class video of April 21st. 2022 to YouTube. The URL is this. Best regards, Wei Zhen. Okay, the next new announcement is the slides of chapter 2 has been updated. Version 2022-0426. Hello everyone, I have uploaded the latest version of slides of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning, course content, slides, Chapter 2 slides 2022-0426.pdf. Best regards, Wei Zhen. Okay, the next new announcement is the handout of Chapter 2 has been updated. Version 2022-0426. Hello everyone, I have uploaded the latest version of the handout of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning, course content, handouts, Chapter 2 handout 2022-0426.pdf. Best regards, Wei Zhen. Okay. Next, let us look at the progress of the last class. Okay, in the last class, we have taught to Chapter 2 slides. Page 38, handout, problem 2 solution in brackets. Okay, please open the handout of chapter 2 and search for in brackets. Okay. So, collecting the future decisions in brackets on the right. The above infinite horizon decision problem is equivalent to, okay, let us review the above infinite horizon decision problem. Okay, so it is this problem. Okay, to maximize this function, okay, subject to the constraints. Okay. Okay, so maximum over A0, okay, over all possible A0, where A0 is the action, okay, taken at time 0, and f of x0, A0. Okay, do you remember what is the function f? Okay, let us review it. Okay. The current payoff from taking action A in state X is f of xa. Okay. So f of x0, A0 is the current payoff function undertaken the action A0 and of state x0, where x0 is the state of at time 0, and plus beta. Okay, beta is the discount factor, and times this term. Okay, let us see maximum. Okay, at. Okay, at is the state at time t. For t is equal to 1 to infinity. Okay, summation t is equal to 1 to infinity, beta to the power of t minus 1 times f of xtat. Okay, where f is the payoff function, current payoff function. Okay, of state xt, and xt is the state at time t. Okay, and undertaken the action at. Okay, subject to the constraints. These are constraints. At is in gamma of xt. Okay, gamma is a set that contains all possible at. Okay, and gamma is a function of xt. Okay, and xt plus 1. Okay, xt plus 1 is the state at time t plus 1 is equal to capital T of xtat. Okay, do you remember what is the capital T function? Okay, let us see. Okay, capital T. Okay, we also assume that the state changes from x to a new state t of xa when action A is taken. Okay. So t of xtat denotes the state, a new state transition from the old state xt, and when action at is taken. Okay. So xt is the state at time t, and xt plus 1 is the state at time t plus 1 for all t is greater than or equal to 1. Okay, subject to the constraints, a0 is in gamma of x0. Okay, where gamma is a set which contains all possible action a0. Okay, at time 0, and gamma is a function of x0, and x1, okay, the state at time 1 is equal to t of x0 a0. Okay, that is x1 is a new state transition from the state x0 and when the action a0 is taken. Here we are choosing a0, knowing that our choice will cause the time 1 state to be x1 is equal to t of x0 a0. Okay, that is this equation. That new state will then affect the decision problem. Okay, here that new state is x1. From time 1 on, the whole future decision problem appears inside the square brackets on the right. Okay, that is inside this square brackets. Okay, square bracket. Okay, this to here. Okay, square brackets on the right. Okay, so we have finished the solution to the problem 2. What is Bellman's principle of optimality? Let us go back to the slides, and please go to page 38. Okay. According to Bellman's principle of optimality, the solution for finding the optimal state value can be obtained in a recursive manner. Okay, you can see that the optimal state value, okay, is v pi I of Si. Okay, it is a function of v pi I of SIT plus 1. Okay, where pi I is the strategy of secondary user I, and Si is the state of secondary user I, and SIT plus 1 is the state of secondary user I at time t plus 1. So you can see that it is a recursive function or recursive equation. Okay, namely it can be obtained by taking the current optimal action, provided that the optimal strategies thereafter. Okay, what is thereafter? Let us see the handout. Okay, search for thereafter. Okay, page 39, problem 1. What is thereafter? Okay. Solution: continuing on from a particular point in time, especially after something else has stopped happening. Okay, it is the meaning of thereafter. Okay, let us go back to the slides. Okay, thereafter are available. Okay, v pi r star star of Si. Okay, what is pi I star? Okay, in equation 2.12. Okay, that is this equation. We denote pi I star as the optimal strategy of secondary user I. Okay, and v star is the optimal value function of Si. Okay, and is equal to minima. The minima is taken over all AI, okay, all possible AI, where AI is the action taken by secondary user I, which is in the set capital A. Okay, do you remember what is the set capital A? Let us review it. Okay, on page 32, capital A is a set of system actions. Okay, and the minima of C of SIAI, okay, where C is the cost function. Okay, do you remember? Let us go back to review the cost function. Okay, you can see that on page 38, the expected sum of costs over time, okay, CT plus 1. Okay, so C is the cost function. And C is a function of Si and Ai, and plus beta I, okay, where beta I is the discount factor of secondary user I, and summation over all Si prime, which is in set capital S. Okay, do you remember what is capital S? Let us review it. Okay, capital S is a set of system state. Okay, so then inside the summation, there are two terms. The first term is P of Si prime given SIAI. Okay, what does this term mean? Okay, let us see here. P of Si prime given SIAI is the state transition probability from Si to Si prime given the chosen action Ai. Okay, so we can know that Si is the old state and Si prime is the new state. Okay, and times V pi I star star of Si prime. Okay, so again you can see that V pi I star star of Si is a function of V pi I star star of Si prime. So again, it is a recursive equation. Where we remove the time instance suffixes t or t plus 1 to unclutter. Okay, what is the meaning of unclutter? Let us see the handout. Okay, let us search for unclutter. Okay, here. Okay, problem 2. What is unclutter? Okay, solution: to remove clutter from. Make neat and orderly. Okay, let us go back to the slides. Excuse me. Okay, to unclutter the notation. Okay, we have seen this point before. Okay, then observing equations 2.8 and 2.9. Okay, let us go to equations 2.8 and 2.9. Okay, in equation 2.8, IIT is equal to 0 if gamma ITS is greater than or equal to gamma I. Okay, then what is gamma ITS? Okay, gamma ITS is given in equation 2.2. Okay, let us go to equation 2.2. Okay, gamma I, okay, here is no T here. Okay, so gamma IS is the SINR for secondary user I. Okay, so we can know that gamma ITS is the SINR for secondary user I at time instance T. Okay, gamma IS is defined as this equation. Okay, which must be greater than or equal to gamma I. And gamma I is secondary user I's required SINR threshold determined from quality of service QoS goals. Okay, let us go back to equation 2.8. Okay, here. Okay, and IIT is equal to 1 otherwise. Okay, and LT is equal to 0 if gamma 0 TP is greater than or equal to gamma 0. Okay, where gamma 0 TP is given in equation 2.1. Okay, let us go to equation 2.1. Okay, in equation 2.1, gamma 0 P is the SINR of the primary user. So we can know that gamma 0 TP is the SINR of the primary user at time t, and can be expressed as this equation. Okay, which must be greater than or equal to gamma 0. Okay, and gamma 0 is the primary user's requirement SINR threshold as determined from the underlay DSA configuration. Okay, do you remember what is DSA? Okay, Okay, excuse me. Okay, DSA means dynamic spectrum access. Okay, let us go back to equation 2.9. Okay, and LT is equal to 1 otherwise. Okay, let us go back to page 39. Observing equations 2.8 and 2.9, we note that the system state at the next time instance depends only on the joint actions of the secondary users. Okay, what is the meaning of this sentence? Okay, first we need to review what is the system state. So let us search for the slides. Okay, state. Okay, here we define the system state at a discrete time interval t as st is equal to iit lt. Okay, st is equal to this pair, where iit reflects whether the interference condition of an individual secondary user I is satisfied as per equation 2.2. Okay, let us see equation 2.2. Okay, equation 2.2 shows that for secondary user I, the corresponding SINR is expected to satisfy the condition gamma is equal to this equation, which is greater than or equal to gamma I, and gamma I is the SINR threshold. Okay, let us go back to the system state, the page of system state. Okay, this page. And LT reflects whether the interference condition of the primary user is satisfied according to the underlay dynamic spectrum access approach. Okay, so we can know that system state ST is equal to IIT LT pair. Okay, let us go back to page 39. Okay. And what is the actions of the secondary users? What are joint actions of the secondary users? Okay, let us search for actions in the previous slides. Okay, the action of secondary user I is defined by AIT. Okay, which is the action of secondary user I at time t, which is equal to PITS RITS. Okay, then what is PITS? Okay, let us search for the slide to review what is PITS. Okay, we know that PITS, okay, let us go farther. Okay, PIS, okay, is the power. This may not be clear. Okay, so that us, okay, see, okay, P1S to PNS are the transmitter powers of all the secondary users. Okay, so let us go back to the PIS page. Okay, PITS is the transmit power of secondary user I at time t. Okay, next, what is RITS? Okay, let us also review it. RITS. Okay, let us search for RITS. Okay. RITS. Okay, here we can see that fixed. Okay, it is 25 minutes. Let us take a break.